Alright, so we have a problem called validated binary search tree. Given the root of a binary tree, determine if it is a valid binary search tree or not. A valid binary search tree is defined as follows. The left subtree of a node contains only nodes with values less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both the left and right subtrees must also be binary search trees. So basically a binary search tree is the left subtree has to be less than the root and right subtree has to be greater than the root. So here on the example 1 we can see we have the root 2 and 1 is less than 2 and 3 is greater than 2. So this is a valid binary search tree. For the second example, we have the initial root is 5, 1 is less than 5, but 4 is not greater than 5, so it's not a valid binary search tree. Alright, so to solve this problem and find out if it's a valid binary search tree, we have to go to each subtree and figure out if that specific subtree is a valid binary search tree or not. So we're gonna traverse through all the node, and eventually if we hit the null node, which means is the end of binary search tree, we can return true. But if we find a case where the binary search tree's definition failed, we'll return false. Okay. So the easiest way to solve this problem would be to use some kind of range where we can define what the minimum is and maximum is for a specific subtree. So for this subtree, we have the root, right? And for the left side, we can define a rule that the minimum is like let's say negative something infinity, and the maximum will be 2, right? Because on the left subtree the value can be greater than 2, so the maximum will be 2. Similarly, if we go to the right subtree, we can define a rule and say the minimum is, here we can say the minimum has to be 2 and the maximum is plus infinity, something like that. So since we'll be using a range, we can define a helper function here, which will be void, of course. I mean not void, because we'll be returning either true or false, so it will be boolean. We can name it validate and can write root or node, whichever you guys prefer. So the base case here, if node is equal to null, that means we have reached the end of the binary search tree, and for that specific subtree it will be true, since we have done traversing through all the node and we didn't find any case where it goes against the definition of binary search tree, so return true. To be honest here, I made a mistake since we have to define the range. So it will be like this: return validate. We're gonna call the helper function here. We'll pass the root. Since we gonna define negative in infinity or positive, very positive number, we can use a long here for the range. So long dot mean value. I hope this is correct as far as the syntax goes. Dot max value. Alright, we're done with the main function here. Okay, so what we're gonna check now is that if the value is not in this range, we'll return false. Okay, so let me update here the parameter in, not int, it will be long mean and long max. So if node.val is less than or equal to mean, or node.val is greater than or equal to max, which essentially means we are out of range, will return false. Now for the most important part, the traversing part, we'll say return for the left subtree, right? Validate node dot left. Now notice here for the left subtree, we have to concern about the maximum, right? Because we are checking if the node's value of the left is not greater than the root itself, so which is nothing to do with the minimum value. So minimum will be same as before, and for the maximum it will be node dot val. Okay, now for the right subtree, can write node dot right comma. So similarly, for the right subtree, we are not concerned about what the maximum is, so we gonna leave maximum as same as before. And for the minimum, we have to make sure the minimum is right, so we can write node dot val for the minimum. Now let's run it. Okay, now let's submit it. Hopefully it'll work. Alright, perfect.